Hello guys, so we're going to show two examples about two power tests and show what they're equal, when they are converge or diverges, and let's get into it. So the first series will be this one. So this one of -1 to the power of 1 multiplied by x to the power of n and 2 to the power of n multiplied by n. So first of all, I use a little bit of algebra to write this. Okay, so they are identical, they're equal. Anyway, now we're going to use this substitution technique. So t equal x divided by 2. And now we can write this as a power series, an ordinary power series that we can easily find the radius of convergence and the area of convergence. So this is the an, so this is the series multiplied by t to the power of n. So this is -1 to the power of n divided by n. So we're going to use the square root test, and this test states that the radius of convergence is equal to 1 divided by the lim sup of the nth root of the absolute value of an. So the lim sup of the an going to be 1. Okay, so the lim of this is 1, and because the limit of this is 1, then r equal 1. So the radius of convergence is 1. Now we need to check the edge point manually. What does that mean? So we have this is the radius of convergence, and we need to check when t equal -1 and t equal 1. So first of all, t equal 1, we are going to plug it into the formula, and t equal 1 is -1 to the power of n divided by n. So this is easy. We know this by the Liveness test that this series converges. So because this is an alternative series multiplied by a series that goes to 0. And now when we're going to plug t equal -1, this is going to be the harmonic series, and this is easily known as divergence series. So for t, the area of convergence is when t is less than -1 and until t equal 1. And from here we can extrapolate that instead of t we can write x divided by 2 and then isolate x, so we have this, so -2 till 2. And now for the second series, we have x to the power of n divided by n multiplied by ln of n. So now we're going to check this, and first of all, here is an. So the series multiplied by n is 1 divided by n multiplied by ln of n. So here we're going to use the ratio test. So these two different tests, they are identical in order to find the radius of convergence. So now we divided these two series, and when we divide these two series, we gain that the limit of this is 1. So you can easily find that this limit is 1 and this limit is 1, so the overall limit is 1. And the radius of convergence is 1. So now we need to check both edge point independently. So first of all, for x equal 1, we have this series. So now we write this as ln of n is always positive in this area, and n is bigger than 2, so it's also positive. And we know this is going to 0, so we can use the Cauchy condensation test. And because of Cauchy condensation test, we can find out that this series converges. Why? Because instead of using the bn, which equal 1 divided by n ln of n, we know that if this series converges, also 2 to the power of n divided by 2 to the power of n ln 2 to the power of n. So these two series are converge or diverge together. So by Cauchy condensation test, we can find out that this series equal this series by using a little bit of algebra. So 2 to the power of n, 2 to the power of n. And now we have this series, which is 1 divided by n multiplied by 1 divided by ln of 2. So we know that the constant multiplied by harmonic series is still diverges. So this is it. And now for x equal minus 1, we have minus 1 to the power of n divided by n multiplied by n. So we know this series going to 0. So all of this going to 0. And we have an, which is an alternating series. Then by the Liveness test, this series converges. So this is the area of convergence, and the radius is 1. So hope you like this video. Please like and subscribe for more videos like this, and until next time.